So in this video, we're going to go over long division of polynomials. We've gone over all of the other operations, adding, subtracting, multiply. So now we're moving on to dividing. Long division of polynomials, you can always use for division of polynomials. So let's start with a review of constant terms. So let's do 3,107 divided by 3. And we're going to do long division. So first, remember, this is the dividend. This is the divisor. And what we're looking to see is how many times does the divisor go into the dividend. So when you do long division, okay, divisor goes outside the long division bar. Now, notice, this has 4 digits. 0, okay, 0 is a placeholder. Do you have to have that 0 placeholder there? Absolutely, because if you didn't have that placeholder there, it would look like this was just 317. So it matters because we need to make sure we represent. This is the ones place, this is the tens place, this is the hundreds place, this is the thousands place. So remember, our number system is in a power of 10, okay? Each unit is a power of 10. Ones, tens, hundreds, thousands. And you have to show that. You can't just forget about that 0 there. Okay, so you have to have that placeholder. So now what we're going to do is we are going to start by working with the first unit, which is the thousands place. And we want to see how many times does this go into the thousands place without going over. So how many times does 3 go into 3 without going over? Goes in 1 time, okay? So we subtract now however much we just put towards what will be the quotient. So we didn't just put the value of 1, we put the value of 1,000 because we're putting it specifically over the thousands place. So then we do 3 times 1, that gives us 3,000. So now we subtract out. Okay, 1 minus 0 gives us 1, 0 minus 0 gives us 0, 7 minus 0 gives us 0. So now what we want to know is, okay, how many times does 3 go into the hundreds place without going over? Well, if it's just a 1 there, it's not going to go in at all, okay? We're not going to have a hundreds place. How many times does 3 go into 10 without going over? Well, we could do 10 divided by 3, that's, okay, whoops, that's 3, right? So we put a 3 up here. 3 times 3 is 9, right? We have a remainder of 1. And so we are going to take away 9, but we're really not taking away 9. We're really taking away 90 because this is sitting in the tens place. The reason there's a 0 here is for the hundreds place. How many times can 3 go into 1? It can't. 3 is larger than 1. So now we've got the value of 10, okay? So now we know we don't have any more tens left because we've got our tens digit. So 10 divided by 3 gives us 3 again with a remainder of 1. So that would be in the ones place. 3 times 3 is 9 with a 1. Now what this 1 represents, if there's no more, okay, we just took care of the ones place, this is the remainder that we have left. So our answer would be, our quotient would be 1,033 with a remainder of 1. So 1 out of 3. That would be our quotient. Okay, so what we get here, this is our quotient. Okay, so this now is what we have to do is take this and translate it to polynomial expressions. In polynomial expressions, you don't just have a constant term, okay? You have multiple terms with powers of x. So instead of thinking about it as power of 10, okay, ones place, tens place, hundreds place, thousands place, we have to think about it in powers of x. So now we're going to move and start doing long division with polynomials. So the first problem that we will do, we're going to divide using long division. We're going to do x squared plus 2x minus 24 divided by x plus 6. So notice this is the divisor, this is the dividend. There are a few things that we need to make sure are occurring before we start using division of polynomials. First thing you need to make sure that you are in standard form, okay? When we work with numbers, if I say 3,124, I can't write it a different way and still be the value of 3,124. But can I take that and write it two different ways and it still be the exact same value? Yes. But remember, in division, we check out from the largest unit, okay, power of 10 down to the smallest. In polynomials, we need to go from the largest power of x down to the smallest. So you need to make sure you're in standard form, and you need to make sure that you are counting up for all powers of x descending, okay, from, well, let's rephrase that. We need to have all powers of x from largest down to smallest. So when we get to that, what that means is, okay, we should have a placeholder. It's not going to be mandatory in long division, but when you learn a different type of division next with polynomials, it will be mandatory. So what that means, what I'm talking about here is, if this was your dividend, notice it does not have a power of x squared. However, your quotient could have a power of x squared, so you want to make sure that you write in a placeholder. That's the difference between just numbers and having polynomial expressions. If I had the number 301, I can't not have the 0 there. But if my expression was this, okay, I don't have to have that 0x squared there to be the same value. So you need to make sure if your expression looks like this, that you put in a placeholder. Is it mandatory for long division? No. But is it mandatory for a different type of division? Yes. So it's probably a little bit easier to do long division when you have your placeholders. Okay, so always check. Okay, so I'm in standard form here, and I don't need any placeholders. I'm in standard form here, I don't need any placeholders. This is my divisor, and this is my dividend. Now, there are multiple terms, so what we did before in the previous problem, you didn't have multiple terms, you just had a number. So what you have to worry about, what you're most concerned with, is the leading term of the dividend and the divisor, okay? That is because if it's the leading term, it always holds the highest degree no matter what you multiply it by with any polynomial term. So what you worry about is the first term of the dividend and the first term of the divisor. Okay? And you say to yourself, how many times does this go into this power of x without going over? So how many times does x go into x squared without going over? Well, you could just make a little note right here. Okay, that's division. How many times does x go into x squared without going over? It only goes in one power of x to the first. So I wouldn't put it over the x squared so everything lines up nice and neat. I would just put it over the 2x, because this represents power of x to the first. Now, we have to subtract out however much we put into our quotient. So we put in, remember, you take this and you multiply it by the divisor. So x times x plus 6 gives us x squared plus 6x. So we just put in x squared plus 6x. Okay, so we got to take that out from our dividend. So x squared minus x squared, those will always cancel. Now we've got 2x minus 6x, that's negative 4x. And negative 24 minus, okay, there's nothing here. Negative 24, bring it down. If you don't like going like this, okay, you could just go like this. It's really plus 0 there. So now we say to ourselves, how many times does the divisor go into the leading term of the dividend without going over? It's just leading term and leading term. So negative 4x over x equals negative 4. Okay, so the constant term of negative 4. So if we just put a value of negative 4 into our quotient, now we have to subtract that out. So take negative 4 and multiply it by the divisor. That's going to give us negative 4x minus 24. Okay, negative 4x minus negative 4x, they cancel. Negative 24 minus negative 24, that's negative 24 plus 24. they cancel, so that means that this has a remainder of 0. So the quotient is x minus 4. So it has no remainder. So if you want to check your work, what you can do is you take your quotient, x minus 4, you multiply it by your divisor, and you need to get back out your dividend, right? That's how we check when we were just working with numbers. If we did 21 divided by 3, 21 divided by 3 is 7. So we take 7 and we multiply it by 3, and we better get 21. Okay, you can still check that way. So let me go over how do you know when you stop doing division and what's your remainder. So you want to know how many times does x go into whatever the leading term is. X can't go into anything that would be a lesser degree. So this leading term, okay, always has to be a larger or equal to degree. It can never be, it either has to be smaller or equal to the leading degree, okay, the degree of what's left in the dividend, okay? It cannot, this term right here cannot have a higher degree than what's the leading term in the dividend. So let's do another. Okay, so we have x to the third plus 5x minus 1 divided by x squared plus 2x minus 1. So if you notice, we have third degree, second degree, they're both in standard form, except this one doesn't have the 0x squared, so I'm going to put that in there. Okay, this is my divisor, x squared plus 2x minus 1 divided by x to the third plus 0x squared plus 5x minus 1. So we've got all of our powers of x. So what we say is, okay, I want to know, here's my leading term, here's my leading term. How many times does the leading term of the divisor go into the leading term of the dividend without going over? So that would be x to the third over x squared. That's going to give us x. So we don't have any powers of x to the third. We don't have any powers of x squared. We just have 1x to the first. Now think about this. This is multiplication. If my divisor is x squared and my dividend is x to the third, what should be the first term of my quotient? Just x. Because you remember properties of exponents. You would be doing x squared times x. That would be adding those exponents, giving you x to the third. So now we have to subtract out what we just put into the quotient. So we take our term that we just put into the quotient and multiply it by our divisor, which is x squared plus 2x minus 1, and that gives us x to the third plus, okay, 2x, I'll write it out here, x to the third plus 2x squared minus x, so x to the third plus 2x squared minus x. X to the third minus x to the third, those leading terms should always cancel. You have 0x squared minus 2x squared. So if you didn't have this term in here, you could still see that there would be nothing to combine this with. But if you had the 5x over this term here, okay, you might, without thinking, accidentally try and combine 5x minus 2x squared, but they're not like terms, so you shouldn't be doing that. So 0x squared minus 2x squared, that's negative 2x squared. 5x minus negative x, that's 5x plus x. These are the most common mistakes that are made right here. 5x minus negative x is 5x plus x, giving you 6x. We bring down the minus 1. Now notice, the degree, okay, the leading term here has the same degree as the leading term here. Okay, that means we keep going. We don't stop until this has a larger degree than this. So how many times does x squared go into negative 2x squared without going over? Okay, simplify that. That's going to give us minus 2. All right. Now we have to take out what we just put in. So now we have to do negative 2 times our divisor, x squared plus 2x minus 1. That's going to give us negative 2x squared minus 4x plus 2. So negative 2x squared minus 4x plus 2. And so now we subtract. Negative 2x squared minus negative 2x squared cancel. 6x minus negative 4x, that gives us 10x. Negative 1 minus 2, that gives us minus 3. How many times does x squared go into 10x without going over? Okay? X squared has a larger power than 10x. Therefore, x squared can't go into 10x. So this is all the remainder. Okay? So the quotient to this problem would be x minus 2, okay, plus, and our remainder, okay, 10x minus 3 over the divisor, which it was x squared plus 2x minus 1. Okay, remember, just like we did in just the number problem, you have to put your remainder over the divisor. You have 10x minus 3 over x squared plus 2x minus 1. Because we didn't even have a full 10x minus 3 term, right? It was the portion of what we had over the divisor. So this would be our answer here. This is our quotient that we would get. So let's practice one more long division. And then we will move on to synthetic division, but we will put that in a different video. Okay. Number 3, let's do 6x to the 4th minus 5x squared plus 7x minus 1 divided by x squared plus 1. Okay, so if you notice, okay, in standard form, but missing placeholders, so I'm going to put my placeholders in. So this is 6x to the 4th plus 0x to the 3rd minus 5x squared plus 7x minus 1, x squared plus 0x plus 1. Okay. Once you get the hang of it, you might not need to put the placeholders in the divisor for long division. I would still put them in the dividend though. Okay, so now we get started. We say how many times does the leading term of the divisor go into the leading term of the dividend without going over? 6x to the 4th over x squared. Okay, so that's going to give us 6x squared. So doesn't go in x to the 4th, x to the 3rd. First power goes in is a power of x squared. So now we have to take out what we put in. So that's going to be 6x squared times the divisor, which is x squared plus 0x plus 1. That's going to give us 6x to the 4th plus 0x to the 3rd plus 6x squared. So 6x to the 4th plus 0x to the 3rd plus 6x squared. Cancels. Now look, 0x to the 3rd minus 0x to the 3rd. So we don't need to have a power of x to the 3rd if there are none, because the leading term that we have right now is going to just be negative 5x squared minus 6x squared, negative 11x squared. Okay, bring down all of the other terms. Okay, so now do we say to ourselves, should we keep going? Yes, because they're the same degree right now. You stop once this is larger than the dividend's degree. Negative 11x squared over x squared, right? How many times does this go into this without going over? That's going to be negative 11. And now we have to take out what we just put into the quotient. So negative 11 times x squared plus 0x plus 1. That's going to give us negative 11x squared. That's going to give us plus 0x minus 11. Oops, sorry. Negative 11x squared plus 0x minus 11. Okay, they cancel. 7x minus 0x, that's 7x. Negative 1 minus negative 11, that's negative 1 plus 11, that gives us plus 10. This is power of x squared. This is power of x to the first. That means this is the remainder. Okay, so that means your quotient here would be 6x squared minus 11 plus 7x plus 10 over x squared plus 1. You don't have to put the x squared plus 0x plus 1. So if you noticed, I put that minus 11, I kind of put it over this. I would just write it like here. Okay, if you have no power of 1x, see you only have x squared and the constant term, I would just make sure everything lines up. I apologize, my handwriting there kind of messed that one up. Okay, have everything just line up so that you're just nice and neat with your work so you don't make any silly mistakes. Okay, line up with the powers. Notice all my powers are lining up so I can keep track of everything. And so my quotient is 6x squared minus 11 plus 7x plus 10 over x squared plus 1. So in long division, okay, make sure your dividend and divisor are in standard form. Put in your placeholders and perform long division. Please make sure that your remainder you put over the dividend, 7x plus 10, over the not over the dividend, over the divisor. The divisor here is x squared plus 1.